Here is an interesting question on transformed polynomials. The question is, write the number of x-intercepts for each of the following. I'd like you to pause the video, copy the question, answer, and then look into my suggestion. Well, the equations given here are very similar. So let's try to figure out their differences. The first one is y equals to 3 times x minus 2, and you'll see 3 times x minus 2 is common in all the four equations. The difference is in the exponent. In the first two, the exponent is 2n plus 1. Now 2n plus 1, where n is set of natural numbers, means odd, right? So here the degree of these polynomials is odd, right? So these two are odd degree polynomials, correct? Now part C and D, the exponent is 2n and 2n, so these are even degree polynomials. Okay. Now let's move forward. A is plus 1. That means the polynomial 3 times x minus 2 to the power of 2n plus 1 has been moved or translated 1 unit up. The question is, write the number of x-intercepts for each of the following. So with the result of this translation of 1 unit up, what happens to the number of intercepts? That is the real question, right? So now, since that is very clear to us, let us try to sketch a general odd degree polynomial and see what really happens. Now x minus 2 means moving 2 units to the right, and plus 1 is 1 unit up. So by default, we can sketch this as our function, right? Now the transformed function has moved 2 units to the right and 1 unit up. That means this point can move 2 units right and then 1 up, right? So in that case, the transformed function could be kind of like this, right? So if that is the transformation, what happens to the x-intercepts? They remain exactly same, right? So in either case, we have just one x-intercept. You see that? Whether I move this up or down, right? If I move this point from here to here, or if I bring it down, even then the graph will be kind of, same, right? So the x-intercept is going to remain as 1. So in case A and B, when the degree is odd, translating the polynomial towards left or right or up and down does not really change the number of x-intercepts. Okay, so that's what we conclude from part A and B. Now let's look into part C and D. In this case, the function is even, right? Even degree. Let's try to sketch it. Now this function, which is also an even function, it's not an even function, but it's even degree function. So general function will be kind of like this, right? So like this. Now this has moved 2 units to right and 1 up. If I move this point 2 units right, 1 up, then what happens? Then what we get is something like this. In that case, if I move it up, then how many x-intercepts do we have? We have none or 0, correct? But if I move this down, then what happens? If I move this point right and down, in that case, we have 2 x-intercepts. Correct? So that is how it changes. So remember one thing, that for odd degree polynomial, translating horizontally and vertically does not change the number of x-intercepts. But for an even degree polynomial, vertical translation changes the number of x-intercepts, right? From 1 it can make it to 0, or 2, right? So that is what we conclude or we understand from this particular example. I hope that helps. Thank you.